This is a contingency table question, and what we have here is a sort of frequency table of the ages and sexes of Derby winners, horse race winners. So we have stallions and fillies, or otherwise males and females, and we have the ages of each 3, 4, and 5. Now, I think it's just sort of a contrived example. I'm not really that sure about horse racing or race horses or anything like that. So what we have here is the fact that we had 110 of them, okay, Derby winners altogether. It seems that there was 60 male stallion winners and 50 fillies, female winners. Also we have a breakdown of the age groups. 30 of them were 3 years old, 50 of them were 4 years old, and again 30 of them were 5 years old. So what is the So what we have to ask to do here is compute the probability that 1, the horse is a filly, the horse 1 is a 5-year-old, the horse was a stallion given that it was a 3-year-old, and the horse was a 4-year-old given that it was a filly. Okay, just a sort of quick remark. First off, these questions down here sort of indicate that in conditional probability is an important matter. How you would know that is the word given is here, or something that's equivalent to given that such and such. Okay, so let's start off with this. So we had 110 Derby winners and 50 of them were fillies. So it's 50 out of 110. Let's just go back here a second. So we have the sum total here of 50 out of 110. This is the grand total down here. 110. 50 of them were Derby winners. 50 over 110. And we get 45.45%. 30 of the winners were 5-year-olds. So the second question was how many of the horses, what's the probability of being a 5-year-old randomly selected from that list. We do something similar here. There was 35-year-old winners. There we have it there. And 30 out of 110 gives us 27.27. Okay. Now, 30 winners were 3-year-olds, and of that 30, 10% were stallions. So, based on the contingency table approach, we're looking at the horse was a stallion, given that it won as a 3-year-old. So we're just looking at this group only. We're disregarding the other 80. And of that 30, 10 were stallions. Okay, so just based on that, 10 out of 30, it is a 1/3, not 33.33%. Now, 50 winners were fillies, and of that 50, 20 were 4-year-olds. So we're looking at the fillies first off. We'll find the probability that the horse was a 4-year-old, given that it was a filly. Let's go green here. So this is the fillies here, and there were 50 fillies, and of that 50, 20 of them were 4 years old. So 20 out of 50, 40%. Now, what I'm going to do here is separately do these same two questions, last two questions again, on the basis of using the conditional probability formula. Oops, wrong question there. So let's do it down here. I'm going to scroll down here a bit so I have a bit more space. So the probability of being a stallion, given that it was 3, let's just say, I'm going to put this Y3, 3 years, but I'm going to put the Y first. So that is the probability of being a stallion and a 3-year-old, again Y3, all over the probability of Y3. Now we're using the same numbers here. We're going back to this here very quickly. So the probability of being a stallion and 3 years old is equal to 10 out of 110, and that's divided by the probability of being a 3-year-old, 30 divided by 110, and we can simplify that to 10 out of 30, and then we're back to where we were started there earlier on, 33.33%. Okay, now the fourth one you can do the same way, but essentially conditional probability formula is something to be taken into account here. The conditional probability formula, and that is, yeah, actually I just sort of make a note of there. Just conditional probability formula. You've probably seen it in other presentations or in your other material. So I'll just leave the video there. Whoops, there we go. This is a short probability question and it concerns independent events. Just giving you a hint there. What is the probability of getting a number divisible by 3 in each of 3 throws of a dice? So we have 3 events, and well, 3 events that are identical, so we're just going to give them all the same name. And we're going to call this event T, and the number you throw is divisible by 3. So it's either 3 or 6. Okay. Now, what is the probability of T in a single throw of a dice? Well, you have 1, 2. This is the possible outcomes of the throw of a dice. 1, 2, 3, 4, 5, 6. You have 6 events, and only 2 of those, or 6 numbers, and only 2 of those numbers are divisible by 3. So necessarily, the probability of throwing 3 or 6 is 2/6, or in other words, 1/3. Okay, so the probability of T is 1/3. Now, we're interested in particularly in 3 throws of a dice. Now, this throws of a dice are independent events. So, throw dice once, throw dice twice, throw dice 3 times, or throw a die even. I should actually correct the spelling there. It's actually a die, not a dice. But anyway, we'll continue. Probability of throwing a 3 or 6 3 times in a row. Each throw of a dice, a die even, is an independent event. We're going to call this event 3T. 3 times we get the same event. Now, or we get a number divisible by 3. So essentially, it's probability of T in the first throw, probability of T second throw, probability of T in the third throw. So all we have there is 1/3. It's 1/3 by 1/3 by 1/3, and if you want, that is 1/3 cubed. But anyway, the answer is 1/27, and you can get a decimalize that 1.03 something whatever if you want, but I'm happy enough to leave it there, not 1/27. Okay, so anyway, the key thing about this was that they were independent events. So we'll leave it there. Whoops.